Hey guys, Paul here. Continuing on my integrated circuit series, today we're going to check out the 4096 Schmitt Trigger NAND logic gate chip. Now the Schmitt Trigger is a lot like the 4011 NAND gate chip, except this chip has built-in threshold for filtering out electronic noise and lends itself particularly well for audio applications. And today we're going to build a breadboard synthesizer with this chip. Let's check it out. Now I've got a lot going on here, but I'm going to break it down pretty simple for you guys as far as you don't have to be using two chips like I am here, 1 and 2. So here's our chip, and pin 7 goes to ground, pin 14's voltage in. And in every configuration that you see on my breadboard with the two chips and everything else going like that, the basic concept is that your input pin goes to voltage in, and the other input pin corresponding to the output goes to a resistor and a capacitor. This is where the magic happens. And then one end of the capacitor is going to ground. Now, from this combination of the capacitor and the resistor, on the output, you're going to have another resistor going into either into any audio speaker source. I have it going into the LM386 amplifier module, which is really great. It's got its own potentiometer. I'm going to show you that in a minute. I've got that going in an 8-ohm speaker, and of course, both of those units go to ground. So that's the basic concept. And then you can, it's a quad chip, the 4096, just like the 4011. So you've got 4 outputs corresponding to 8 inputs. Now, on my configuration today, what I've done, and this is kind of like trial and error. On the first gate, I've got 100 microfarads going into a 10K resistor. You can use pretty big resistor values with these breadboard synths. 496 is really good as an oscillating chip. So you're hearing that back and forth. What really interested me, why I brought out the second chip here, is I wanted to see if we could offset the oscillations, because on one chip, you're getting kind of a constant oscillation no matter the outputs, it seems to me. So I thought maybe we would get a slight juxtaposition between the two oscillations by putting 2 chips on the board. And I am getting a slight deviation. What it is you've got it. Now I've got a 10K potentiometer trimmer pot here, with the middle pin connected to the, the middle pin is the wiper input, which is actually the wheel inside the pot. And I've got that connected to my output on pin 3 from the second chip. So you don't need to do this, but I'll tell you, once you start messing around with this stuff, it becomes so much fun that you just kind of keep seeming to add on stuff, I'm noticing. And then I've got a 10K pot as well on the LM386 amp module. So between adjusting these 2 pots, you can get a range of sounds. One thing I want to mention is no matter how you configure this is to keep separation between your resistors, because if they touch each other, that's going to be no good. They'll kind of like short each other out. So keep separation. Also, the order in which you place your resistors, connect your resistors from the output pins to the input on the amplifier module or speaker matters. You can change the kind of how much signal is coming through each output pin in the order leading up to the main input pin to your speaker. Nice. Cool.